Hi, my name is Ketul Shah. I'm a PhD student at Johns Hopkins University and I'll present our work titled Multi-View Action Recognition using Contrastive Learning. For this problem, the training set consists of labeled synchronized multi-view videos of each instance. Our goal is to learn to extract features robust to changes in viewpoint for the task of action recognition. Recent advances in multi-view action recognition are heavily focused on skeleton-based methods. This assumes access to 3D pose information which may not be available in datasets collected for real-life applications. An alternative is to estimate the skeleton pose, but these methods are often slow and inaccurate for complex scenes. Hence, in our work, we focus on RGB videos which are most readily available. We employ the widely and successfully used framework of supervised contrastive learning for achieving robustness to varying viewpoints. We also introduce an effective way to select hard negatives for quickly learning a more discriminative feature space. First, I'll describe our contrastive learning framework. In contrastive learning, for an anchor, we have a set of positives and a set of negatives, and the aim is to pull positives closer together while simultaneously pushing the negatives farther. This is the original supervised contrastive loss, where I is the anchor, P is a positive, and Pi and Ni are sets of positives and negatives for anchor I. Note that in this formulation, one positive is being discriminated from other positives. We remove terms involving other positives from the denominator and use this improved supervised contrastive loss in our method. For an anchor clip, the set of positives and negatives are defined as follows. Positives include augmented version of the anchor, synchronized clips from other viewpoints corresponding to the anchor clip, and clips from other videos with the same label as an anchor. And negatives are sampled from videos having different class label. I will now describe a technique for hard negative selection. The key insight is that harder negative classes have higher posterior probability value compared to easier negative classes. For an anchor instance XA, suppose the posterior probability distribution from the classifier is as shown. Among the two negatives I and J shown here, I is more likely to be confused with the anchor than J based on the posterior probability values. Hence, I is weighted higher than J. Each negative term in the denominator is multiplied by its weight, resulting in a hardness-aware supervised contrastive loss, which we use. Here we compare our approach to other methods using RGB modality and show that our approach outperforms them on standard benchmarks and in transfer learning setting. Also, collecting synchronized multi-view videos at scale without privacy concerns is a big challenge. Creating synthetic datasets solves all these issues. We train our model on synthetic multi-view videos from the RoCoG dataset and test on the real data corresponding to same action classes. The domain gap reduces on using our approach compared to the standard training. Thank you for listening.